how food is preserved over long periods of time? Or how cattle feed can be stored for up to 6 months? Well, the 1945 chemistry Nobel Prize winner Artturi Imari Virtanen found out how. Artturi Imari Virtanen was born in 1885 and grew up in Finland's capital city of Helsinki, where by his early 20s he attended university to study physical chemistry, enzymology, and bacteriology. In 1920, he began his career working for the Finnish Cooperative Dairy Association, and in 1923 decided to switch focus to biochemistry. In under a decade, Virtanen became a professor and began conducting experiments at a routine pace, earning multiple honorary degrees and memberships among institutions. In the 1940s, during the height of his career, Virtanen's attention shifted to isolating amino acids, which are the building blocks for proteins, and switched to studying organic sulfur compounds from plants and started to test their efficacy in human and animal nutrition supplementation. At the time, far less knowledge was known about the chemical composition of foods and its different nutrient makeups, paving the way for many brilliant discoveries, including his 1945 Nobel Prize. It is important to note that there is a great parallel between Virtanen's experiments and that of the various ones we did as a chemistry class this year. In our class labs, we often created hypotheses using the scientific method, similar to how it was performed by Virtanen and his group of scientists. Specifically, this year during Experiment 11, for example, we learned about pH and pH indicators. We were able to gain a better understanding of what pH is and how it relates to the concentrations of strong acids or strong bases, similar to the VIA's method, which will be explained in detail further in this video.
Okay, now we will delve deeper into the concepts of the AIV method and how we can see similarities and what Artturi Virtanen's works did in some of the concepts we learned this year in chemistry. Fermentation may be a desire to produce certain foods like kimchi, beer, or cheese, but it is damaging to foods that need to be stored, reducing their nutritional value. The AIV method sought out to reduce the fermentation that occurred in dairy cows' fodder during the winter. We learned that generally speaking, compounds with higher acidities are less likely to ferment. Knowing this, Virtanen tried to come up with a solution to be added to the organic material that would prevent its fermentation. After many trials and tribulations, he came up with a solution of formic acid, water, and sulfuric acid, known as the AIV method. The AIV stands for his initials. Basically, this solution would be added to the cow's fodder or food to reduce the fermentation due to its acidity. As mentioned before, the solution added to prevent the fodder from fermenting consisted of water, formic, and sulfuric acid. Yet, the solution had to be precise with specific ratios of the bases to acid. Virtanen realized that the ideal solution would be 76% formic acid, 5% sulfuric acid, and the rest water. This was called the AIV solution. This would be an acid-to-base ratio of 5:1. This is not a chemical process, as solutions generally refer to a liquid consisting of diluted or dissolved substances mixed together in a physical process. The Nobel Prize-winning AIV liquid was a solution just like this. Virtanen was educated in topics of science from a young age at the Classical Lyceum for his grammar school, and then he attended the University of Helsinki, learning about chemistry and other types of science. Since a young age learning these concepts, he ingrained these skills in Virtanen's mind. In September, we reviewed the ideas of a hypothesis like Ryan discussed. Artturi Virtanen had to come up with a hypothesis before conducting his AIV experiments that the acidity would prevent fermentation in the fodder or silage. After the implementation of the AIV method, cows would consume food of equal nutritional content in both winter and summer, meaning people consumed healthier products year-round. The 1945 Nobel Peace Prize was awarded to Virtanen because he thought outside the box and contributed to a better planet.